right, Joey, this is to go over some of the questions you were asking about on the CR that you brought in today to work on, the ones we didn't get to together. I don't know what the actual CR number is, but you were asking, I took some pictures of the CR before you left, and number 7 is what we left off on. So it says the manager of Blast Off's barbecue sauce kept track of the number of cases sold during 1 month. She recorded the data in the table below. So during that month, they sold 55 cases one day, 60 the next day, 55 the day after that, 60 cases the day after that, and so on for the whole month. Display this information in a line plot. Okay, so I'd make a line plot. You might call it a dot plot. Zero's way over here. I'm not going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. But your teacher may want you to. I'm just going to plot the data that I see here. 0's the lowest number. So there was a day that they sold 0 cases. And there was another day where they sold 0 cases. Nobody bought barbecue sauce those days. Then I see there was a day they sold 10 cases. So I put a little X there to represent that. Then I look, what's the next smallest number after 10? I see a 35. Is 35 the next smallest number? So your teacher might want you to space it out and jump over to 35. I'm not really spacing it correctly. But there's 35. Like she might want you to do 0, 5, 10, 15, 20, 25, 30, 35. I'm not spacing it like that for you. I'm just putting the numbers along the bottom. So there's a 35. Is there any other days that they sold 35? I don't see another 35. Next I see is a 40. So there's a day where they sold 40 cases. Is there any other days where they sold 40 cases? I don't see another 40. I see some 45s. So if I look for the days they sold 45, there's a day they sold 45. I'll put an X for that. There's a day they sold 45. I'll put an X for that. There's a day they sold 45. I'll put an X for that. There's a day they sold 45. Okay, so there was 1, 2, 3, 4 days where they sold 45. Next one we'll check out is 50. Did they sell 50 anytime? Oh, there's a day that they sold 50. So there was one day that they sold 50 cases. Let's look at 55 cases. One day. There's another day that they sold it. I skipped over one. There's another day that they sold 55 cases. There's another day that they sold 55 cases. I bet the average is around 55. There's another day they sold 55 cases. There's another day they sold 55 cases. There's another day they sold 55 cases. And there's another day they sold 55 cases. So it looks like 1, 2, 3, 4, 5, 6, 7, 8. There was 8 days where they sold 55 cases. See how many times they sold 60 cases. 1, 2, 3, 4. It looks like 4 days. 1, 2, 3, 4 days they sold 60 cases. Looks like there was one day they sold 65 cases. And it looks like there was a day they sold 70 cases. And now I think I have them all. Let me just make sure. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. So that's 24 days total. I just counted up how many boxes there were. So let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And I wrote a 70 up above the 70. I was supposed to put an X there. 24. So we have our line plot showing what happened over 24-day period, how many cases they sold. So that's part A. Part B is what is the mean of the set of data. For the mean, you add up all the data. Add up all of the data. And then you'll divide by your number of pieces of data. There's 24 pieces of data there. So we got to add all of these up. Okay. Well, a quick way to add these up, see how there's 2 zeros? I could do 2 times 0 plus, there's 110, plus, there's 135, plus, there's 140, plus, how many 45s is there? 1, 2, 3, 4. So I could do 4 times 45, and then I could add on 150. I'm going to have to keep my pluses going here. And then how many 55s? 1, 2, 3, 4, 5, 6, 7, 8. So I could do 8 times 55. How many 60s? 1, 2, 3, 4. So I could do 4 times 60. And then I have 165 and 170. What I'll have to do is I'll have to add all those together and then divide that answer by 24 because there's 24 pieces of data. That's how you'd find the mean. Got to add them all up and then divide by the number of pieces of data. So I'll go ahead and try that. 2 times 0 is 0 plus 10. Then on my calculator, I can just do plus 35 plus 40. Plus, you have to do 4 times 45 plus, there's just 150, plus, you have to do 8 times 55, plus, and let's hope I don't make any mistakes here. It is what it is if I do. There's 4 60s, so we have to do 4 times 60 plus a 65 plus a 70. Now, I'm not going to say for sure that I got my sum right, but I came up with 1130. So I would, once you add all your numbers together, you get 1130, and then you have to divide by 24 to get the mean. This is to find the mean. So if you take 1130 and divide by 24, you come up with 47.08. It's 0.83 repeating. I'm going to hit the back and forth arrow so I can put it in fraction form. It's 47 and 1/12. So the mean is 47 and 1/12 because they don't ask us to round. But you could have also written that as 47.08 with the 3 repeating. 47.08 and then just the 3 repeats. Either way. So that's our mean. Mean means average, so the average is 47 and 1/12. What's the median? Median is the middle score. It's the score where exactly half the data is below, half the data is above. So I got to start figuring out where the middle is. So what I'm going to do is I'm going to start here at 0, and I'm going to go to 70, I got to zoom in, I go to my next 0, I go to my 65, I go to my 10, I go to my 60, I go to my 35, I got another 60, I'm trying to zoom in on the middle, I go to my 40, there's another 60, I go to my 45, down below, and there's another 60, there's my next 45, get rid of a 55, there's my next 45, get rid of a 55, there's my next 45, get rid of a 55, then I go to 50, up to 55, then I'm down 55, up 55, down 55, up 55, obviously 55 right here is, I think right around there was the middle, half the data was below, half the data was above, so the median score would be 55. And it says, would the mean or median be a better measure of central tendency? Okay, here's the dealio. The median is definitely the better measure of central tendency in this case because the 0 values, there's 2 0 values way down here, are outliers. And when you have outliers, you want to use the median because outliers, those couple of low values, drag the mean down too low. If you look at average, what's happening, most of the data is up here in the 50s or mid 50s, low 50s, around 60. That's where most of the data occurs. 47.5 is a little too low to consider, and the reason the mean got pulled down was because of these outliers. If they hadn't had those 2 0 case days, you know, who knows, maybe there was a power outage, they couldn't sell anything, then the mean would have been better. But because of these 2 0 days, it dragged the mean down, and you want to use the median. So you want to be able to describe when you have outliers, a couple of wacky values that are way away from the rest of the values. You need to use median for your central tendency. It's a better measure when you have these crazy outlier values. So that was number 7. Let's go ahead and take a look at number 8. Number 8 says, solve the following equation. 6, and then in parentheses, 2x plus 5 plus 3x equals negative 30. We're working on some questions like this today where you had to distribute. There's a number outside a set of parentheses. You're going to multiply that through the parentheses. 6 times 2x is 12x plus 6 times 5 is 30. Keep your plus 3x equals negative 30. So all I did to start was distribute that 6x through. Now on this side, I'm going to combine like terms. Miss Pearson would call it your x's and your no's. So what I'm going to combine together is 12x and 3x. What's 12x and 3x? If you did your little chart off to the side, if you did your x's in your chart, you do your 12x and your 3x, and what do you get when you add those together? 15x. So when I combine those two, I get 15x. I still have my plus 30. Didn't do anything with my 30 because we have to keep the equal sign and keep whatever numbers on the other side of that equal sign. So all I did was combine like terms there. 12 and 3 is 15x, 12x and 3x. All right, now you like to draw in your little ladder, and you can do that. We're going to go ahead and solve this equation. So I got to move all of my constants over to the right. How do I undo this plus 30? I'll have to subtract. The opposite of addition is subtraction, so I'll subtract 30 on the left. If I'm going to subtract 30 on the left, I have to subtract 30 on the right. Those 30s are gone, they zero out, so I'm left 15x on the left side of my equal sign. I keep my equal sign. Negative 30 minus 30 more is negative 60. Now I have to solve for x. The operation between the 15 and the x is multiplication. How do I undo multiplication? I undo multiplication with division. So I'll divide this side by 15 in order to get x all by itself. If I'm going to divide the left-hand side by 15 of the equal sign, I have to go to the right-hand side and also divide that by 15. A negative divided by a positive is a negative. 60 divided by 15 is 4. X will be equal to negative 4. Please make sure you're using your calculator to support you. You do get to use that on your final exam. This one right here, it says the graph below depicts the approximate relationship between liters and gallons. According to the graph, 1 gallon is approximately how many liters? Well, you have a straight edge to help you. Here's your gallons. So this would represent 1 gallon. You'd want to go up from 1 gallon and see where it hits the graph for liters. I'd say it looks like it's hitting somewhere around here. Maybe it goes right up to that dot, I bet. I bet that represents 1 gallon right there, right up at that dot. So how many liters would that be if I go up from 1 gallon? I'd say right about there looks like about 3.75 liters. Seems reasonable, seems a little higher than 3.5, but not quite 4. So I would say 3.75 liters. The graph shows that 1 gallon is the same as 3.75 liters. You just go ahead and check your graph out for that one. All right, let's see if we can fit this last one in a minute. David works at a grocery store. One afternoon, 17 cans fell off the shelf. Then David picked up the 17 cans and put them back on the shelf. Which of these can describe the net change? Okay, well, 17 cans fell off. Negative 17 would represent the cans that fell off. Then he picked them up. He added them back onto the shelf. You'd add them back on for picking them up. Picked up those cans. And what's the overall change? Oh, there's not actually a change on that shelf. 17 fell off. You put 17 back on. The net change would be 0. As long as you pick back up what fell off, the actual number of cans on the shelf doesn't change. So it'll be letter B. I hope that helped, Joey. Try to have a good night. Take care.